Hi, this is Calculus 12, Chapter 3.7. We're going to be looking at implicit differentiation. Some equations are hard to express in terms of y, so an easier way to find the derivative is to use implicit differentiation. For example, x cubed plus y squared equals 15. This, we can do an explicit function for y, but we're going to use this as an example because it's a little bit easier to start off with. And what we wanted to do is differentiate each term with respect to x. And y is a function of x, so we can use the chain rule to isolate dy dx. And we can view dy dx as y prime. But we'll start with Leibniz notation because it's easier. Okay, so we want to find dy dx, but we need to do d dx on the whole expression. So really we wanted to do this, d dx. Okay, but we'll break this up into terms, d dx, x cubed, plus d dx, y squared, and d dx, 15. Okay, we know how to do this. There's only x's involved, so we just use the power rule. So we have 3x squared. Here, we want to use the chain rule. That's the best way to think about this. We want to do dy dx and d dy, and all for y squared. And the derivative of a constant is 0. Okay, so let's just take a look at this. This is how we think.
This is important.
Again, we're not actually canceling, but if we look at the dy's, if we think of it as canceling, then we're left with d dx. So nothing's changed. So now we have dy dx, which is y prime, and we have d dy. So if we're doing d dy on y squared, it's only one variable, and we're taking with respect to that. So this is easy to take a derivative of. So we're left with dy dx, and that's 2y. We move the 3x over to the other side, so this is minus 3x squared. And lastly, we want y prime equals, and we bring this over to the other side, so we have minus 3 over 2 x squared over y. Okay, we want to do it at the point 2 root 7. So we just substitute 2 for x and root 7 for y, and we get our answer. So y prime of 2 root 7. So this is just saying x is 2 and y is root 7. Functions can have 2 parameters. It can actually have more than 2 parameters. So we have minus 3, 2 squared over 2 root 7. One of the 2's cancels out. So we have negative 6 over root 7. Okay, and if you want to rationalize that, we would have negative 6 root 7 over 7. Not all implicit equations are set up the same, but you can follow these rules generally. We differentiate each term with respect to x. We collect the dy dx terms on the left-hand side. We factor out dy dx, and then we isolate dy dx. Okay? And again, you can use y prime once you understand what you're doing. Okay, instead of dy dx. It's a little bit more of longhand to write dy dx all over the place, so you can substitute that with y prime. But understand, whenever you do a y prime, you're doing d dy. And you only need to do dy dx when there's a y in the term. So we don't do it on this term because there's no y's. Okay, and there's no x terms in here, so we don't have to do d dx anymore. We want to break it up into dy dx, d dy. Okay, let's look at a harder example. Okay, we just need to find y prime. We don't need to find the slope at any point. So let's start this off. We have d dx of all the terms. X squared y squared plus d dx x cubed. We've done that one already, so it shouldn't be difficult. Plus d dx y to the power of 4 and d dx of 20. We start with this because it's easy, so that's 0, derivative of a constant. Here, we want to do y prime and then the derivative of this. Okay, so we're doing dy dx and then d dy of y to the power of 4. And we always want to put the y prime last by convention. 4y cubed y prime. Derivative of this, 3x squared. We want to think of this as uv. This is a product, so we need to do the product rule here. So hopefully you've learned the product rule well enough to follow along. So we want to do u prime v plus uv prime. So the derivative of this, that's 2x, and then we have y squared. Now we want x squared, and the derivative of this is 2y, and then we have to add the y prime. Okay, we need to keep this on the left-hand side. This goes to the right-hand side. And we want to factor out a y prime. So y prime, that leaves us with 2x squared y. We want to order our polynomials. Constants first, then alphabetical order. 4y cubed equals negative. And we'll do this with brackets because these are both going to be negative coming over to the other side. We want to do the highest order first. This is order 3, this is order 2. So 2xy squared plus 3x squared. And now we divide this side by this factor. So y prime equals negative 2xy squared plus 3x squared over 2x squared y plus 4y cubed. Okay, if you didn't want to do the brackets, you can just do minus this, minus that. So as I said, we want to think of it as dy dx, d dy, but this is what we do. Because it's easier to read. Okay, we're going to look at a harder problem. Find the second derivative of the first example. Okay, that was the x cubed plus y squared equals 15. So we'll start off with what we left off with. So we're going to do the derivative of negative 3x squared over 2y. Okay, so this is a quotient. We need to use the quotient rule. So this is u, this is v. We need u prime v minus uv prime over v squared. So we need lots of room for this. So the derivative of this is negative 2x times v, that's 2y, minus u, that's negative 3x squared, and v prime. So we're doing d dy of 2y, that's just 2, but we need y prime. Okay, anytime you're taking the derivative of the second variable, we need to do the derivative of that variable. Okay, and then we need to square v. So that's 2y. Put brackets around this so that you don't miss squaring the 2. Now let's just clean this up a bit. We have 2, 4, and 12. Negative 12 xy. We got 2 negative signs, so that's positive. And we have 2 times 3, that's 6 x squared y prime. And now we have 4y squared. Okay, this is a problem. We can't leave this in our answer. So what we have to do is substitute our y prime back in. So negative 12xy plus 6x squared, and we're going to put negative 3x squared over 2y, and that's all over 4y squared. Okay, this needs to be simplified. We can't have fractions in fractions. Let's cancel. That's a 3, and that's canceled. Okay, so we have a y in our denominator, so we need to multiply this by y. We have a y in the denominator of the numerator, so we can slide that down into the denominator. I hope you followed that. Okay, so we're going to multiply this by y over y. There's a y here in the denominator, and there's a y here in the denominator, so it's just going to come here. So we have negative 12x y squared. There's one minus sign, so minus a 3 and a 3, so that's 9. X squared, that's x to the power of 4. And then we have 4y cubed. And that's our final answer. Okay, you could try implicit differentiation. You would move the 2y over to the other side to make it easier, but this is a product rule. So you'd have 2y y prime plus 2y y double prime equals negative 6x. This becomes y prime squared. It wouldn't be y double prime. So you have to put y prime squared. So you avoid doing the quotient rule, but it becomes a little bit trickier to remember this step. And then I'll let you examine the rest on your own. But you end up with the same answer. I really suggest that you follow this one. Okay, let's look at one example with trig in it. Let's just follow the steps. Okay, so we're going to differentiate each term. d dx, 7x squared plus d dx, 3x cos y equals d dx, xy. Okay, we have an x and a y, we have an x and a y. So product rule here, product rule here. This one's straightforward, 7 times 2x. So derivative of 3x is just 3, and then we have cos y. Then we have 3x. We're doing the derivative of cos y. So that's negative sine y, and we have a y prime. Okay, the derivative of x is just 1, so we have y. And then we have x, and the derivative of y is just y prime. Okay, so that's another product rule. Collect the y prime terms, on the left-hand side, put everything else on the right-hand side. And we're going to factor out a y prime right away. So this is negative 3x sine y. And here we're going to have negative x. We'll start off with x's, alphabetical order, so negative 14x. And then we're going to go with y, and that's a positive y. And then this one's going to be negative 3 cos y. And then now we can divide both sides by this. Now there's 4 negative signs. So there's negative on the top, negative on the bottom. So we're going to cancel out all the negative signs and just make this y negative. So 14x minus y plus 3 cos y over 3x sine y plus x. And that completes this lesson.